Hi, I'm Luigi from CBRC University, and today we're going to discuss a topic close to my heart, which is programming. So, I've been programming for almost a year now, and it has certainly stolen my heart the very first time I saw it. Some people say programming is difficult, but here at CBRCs, we try to make these difficult things easy for you. So let us undergo the basics of programming. So this is just an introduction to computer programming, specifically C programming. So what is programming? Programming is much like human behavior and thought, which are characterized by logical sequences. So programming is a, for example, a queue, which there is a start, then there is a end, then it usually goes in a sequence, like from top to bottom or left to right. So here's an analogy of programming to human life. Since infancy, you have been learning how to act, how to do things, and learn to expect certain behavior from other people. Much of what you unconsciously, much of what you do unconsciously, you once had to learn. So usually, all the things that you learn has been programmed to you by your parents. So actually, programming is not only in the computer, but also can be applied in real life. So basically, when a teacher teach you and you learn something from it, that is basically programming. So programming is defined as the process we engage in. It is planning or scheduling the performance of a task or event. So next, we should first, before we start the program, we should know these key terms. So what is a computer? I think everyone knows what a computer is. A computer is a programming device that can store, retrieve, and process data. Nextly, computer program, a sequence of instructions to be performed by a computer. So this is the program which the computer will run. Nextly, the computer programming, which is the process of planning a sequence of steps for a computer to follow. So this is the process which will we try later. Okay, so first, let us know how to write a program. So there is a two-phase problem when writing a program. First, we we try to solve the problems in our heads. We call this the problem solving phase. So in the problem solving phase, we first analyze the problem given to us. Uh, it is said here that we should understand the problem and what the solution must do. So the next thing here is the general solution. The general solution is most commonly known as the algorithm. So algorithm is just a fancy word for solution. So here we should think of a sequence of steps in which the program should run in order to fulfill the given problem. So the next stage we have is the verification. So we should follow the steps which we uh, which we created in our algorithm and verify if it was really correct, if it really does solve the problem. So the next phase of the our two-part phase is the implementation phase. So here we have the concrete solution, which is the program itself. We should translate our algorithm into a program, maybe in Java, Python, C Sharp, or C++. And now, since we have translated our program in, since we have translated our algorithm into a program, we should now test it. We should now test for maybe bugs, maybe logical errors, maybe and other errors encountered in the program. So once we see these errors, we should always make sure that we correct these errors so that we would get the correct output for our program. So nextly, we have here assembly machine code. So these are some examples of programming languages. Firstly, we have assembly language, which is a low-level programming language where there is a very strong correspondence between language and architecture's machine code instructions. So in assembly language, it is considered a low-level language because it is very close to the computer architecture itself because as it directly talks to the computer itself. While in the next example of a program here, we have Python, which is a type of programming language where you may use an IDE, and it is a high-level programming language you could where it does not directly talk to the computer, but it uses the compiler. So next we have here some common programming concepts. So algorithm, which is a step-by-step procedure for solving a problem in a finite amount of time. So what I said earlier, algorithm is just a fancy word for solution. Next one is programming language. This is a set of rules, symbols, and special words used to construct a computer program. So these are what we type in the computer language itself. Recursion, a function calling itself until a condition is met. Okay, so this term may be a little advanced for you, but we will talk about this in depth in the next topic. So be sure to watch for those. Well, the next one is the flow of the control structures. So we have here the sequence, the execution of program one line after another. So usually all programs execute from top to bottom. Well, the next one is selection, selective execution of program based on some conditions. It may be if else or switch statements, which we will discuss later. So don't worry, you will understand this in a while. The next one is iteration, which will repeat the execution of a selected code until some condition is met. So this may be do while, or for. So next we have the programming language's background. So what is a machine language? Language made up of binary coded instructions that is used directly by the computer. So the machine language is basically the binary numbers that we all know, which is the 10101010. It is basically how the computer understands the program. So actually, we don't need to understand machine language as it is very complicated due to the numerous 101010s that we will encounter. So the next one is assembly language. In assembly language, instructions are easy to remember and form. It is an assembler, which means that program that translates an assembly language program into machine code. So the assembler uh, is what talks to the computer itself in order to translate your code into machine code for it to be binary numbers. So here, like what I talked earlier, we have the high-level programming languages like Java, Python, and C Sharp. These programs contain a compiler, a source program, and object programs. So a compiler is basically what compiles your program. It is what uh, talks to the computer in order for your program to work. The next one is the source program. This is where you will put your source codes, while object program is a advanced topic which we will learn in the next module. So be sure to watch out for those. So let us move on to the history of the language which we will learn today, which is C programming. So C is the successor to the language B. So C wasn't just a randomly thought name. It was actually a successor to a programming language called B. So B was developed by Ken Thompson in the 1970s while working on the DEC PDP-7. The B language was a bit restricted, so that is why they created the C language in order for us to have a better control of our program. So the C was developed by Dennis Ritchie and Ken Thompson in 1972. It was not popular until the book The C Programming Language was wrote by Brian Kernighan and Dennis Ritchie. So as you can see that C is a very old language. It has been around since the 1972. So I think that it will be a pretty hard language to understand. Pero with CBRC, I'll make these easy for you. So now let us move on to the programming itself. Okay, so now let us tackle these sample C programs right here, so we could better understand C programming. So let us tackle the basics first, which is the printf. The printf basically just prints whatever you type in the command into the console. So for example, let us type it right here. Let's first type include stdio.h, then int main, then let us try printf hello world. Oh, sorry. Okay. So now that we have printed hello world, let's type turn 0. Then let us run the program. Okay, so as you can see here, the program the console just printed hello world in the console. So that is what the printf function does. It it prints a word or number or any character into the console itself. So nextly, let us try some variable declarations. So this is like algebra where we define variables like x and y. So first we should uh in C we should declare these variables in the topmost part of our program. So since we want integers, we will type in int. Int is a shortcut for integer. And let us try maybe x and y. So here we declare the variables that we want to use in our program. So for for these variables to get values, we just apply the things which we learned in our math class, which is x is equal x is equal to maybe 10 and y is equal to 20. So we can just print these to see if x and y really got the values of 10 and 20 respectively. So to print integers into the printf using the printf, we type in %d for each variable used. So since we have two variables used, we will put x equals %d and y equals %d. So after that, we would add a comma, and after that comma, we would put the variables which would which will be printed in the percent d function. So we would like to print x and y. So we type that in, and let's print that now. So as you can see, uh, x did get the value of 10 and y did get the value of 20. So how about let us try maybe addition, for example. So you could add both of these variables into you could add these variables into using a single printf statement. So let me type the sum of x and y. So right here, since wait, I forgot to type the percent d. Okay, so as you can see here, since we only have 1% here, and we want the sum of x and y, what should we type here after the comma? So we should we should type x plus y, which would output the sum of 10 and 20, which is 30. As you can see here, the sum of x and y is 30. Okay, so if you think this is some super basic stuff, let's move on to something different, which is what I discussed earlier, which is the conditional statements. So these conditional statements are usually if-else statements, which will which will be selective in programming. So wait, let me type in my code first, then I will discuss them with you. So let me type int value. So printf enter a number, scanf percent d ampersand value if value mod 2 equals f number is even, else printf number is odd. Okay. Now, since we've typed our program right here. Oh wait, I forgot to type in the backslash n. So the backslash n is what adds. It's basically like when typing your essay, it's like pressing enter, so it moves on to the next line. So that's what backslash n means. It means go to the next line. So here in our sample program, we could see that uh, the user should enter a number via the scanf. Okay, wait. So I haven't discussed the scanf. So the scanf is the function which will get a input from the user. For example, like this scanf function will get a number from the user, which we will use in the program here. As you can see that here it is said that if the value entered modulo 2 is equal to 0, the number is even. So I think you guys are not familiar the with the function modulo. So let me discuss it right here. So okay. So modulo is basically the remainder of something. So for example, we have 10 modulo 2. So what is 10 divided by 2? So 10 divided by 2 is 10. Oh, wait, sorry. 10 divided by 2 is equal to 0. And its remainder, I'm equal to 5. I'm sorry. Equal to 5, remainder is 0. So 10 modulo 2 is always equal to remainder. So it is equal to 0. So let's try another example, like 12 modulo 5. 12 modulo, okay, 5. So, okay, so let's think of 12 divided by 5 first. So what is 12 divided by 5? I mean, yeah, actually, yeah. 12 divided by 5. So 12 divided by 5 is 2, remainder 2. So 12 modulo 5 is equal to the remainder of this, which is 2. So it is equal to 2. So basically, modulo means that uh, it is when using division, it is the remainder of of the computed division of what you computed. So like what like my example earlier here, it is the remainder. So here value mod 2, if it is equal to 0, it is even. Else is odd. So what the if statement does here is it checks it validates, it checks if the statement written in the if clause is true. So as you can see, let us run the program now. So it says enter a number. So maybe I should enter 5. So is 5 an even number or a odd number? So as we all know, 5 is an odd number. So it should print number is odd. So here we saw that since 5 modulo 2 is not equal to 0, it then moves on to the next conditional statement, which is the else statement. And the else statement says that it should print number is odd. So what if we try to input an even number, for example? Let's try 6. So here now it prints number is even because 6 modulo 2 is equal to 0. That's why it it went down it went down to the if statement and printed this statement, which is number is even. Now it exits the program. Since after you run a single conditional statement, it actually exits the whole conditional statement uh whole conditional statement clause because it already executed the one you wanted. So now let us move on to iterative statements. Iterative statements are pretty uh, maybe confusing at first, but with some practice, I think you'll get the hang of it. So first, let's declare int I, and then let's int sum. So print, let's print f. So what I want our program to do is to print the sum of numbers 1 to 10. So let me type, this will compute for the sum of numbers 1 to 10. So now let us type in the for loop, which is the iterative statement. So I should be 0, then I is less than 11, less than 11. I mean less than 10. Then I plus plus. So here we type then sum equals sum plus I. Oh wait, actually I got it all wrong. Since it is sum of 1 to 10, why did I start with 0? I should start with 1. Okay, so let me explain what I did here. So here in the for loop, we have we have two semicolons which separate three statements. The first statement says I equals 1. So this I equals 1 defines the base case. For example, the first value which you would want to iterate over. While the next statement after the semicolon is the validation statement. In this statement, you will check whether if this statement is already is already if this statement is said to be true, the loop will therefore exit. While the last statement just could be present or not, but it is usually present in the for loop, and it means that it just adds one. It just adds one to I. So okay. So to better understand this, let us return to the whiteboard. Okay. Wait, okay. So we have for I equals 1, I less than or equal to 10, then I plus plus. So with this statement, we have inside sum equals sum plus I. So first we start, since sum is, okay, I forgot that. You should always put this sum equals 0. Okay. So since sum equals 0, so we should like in computing for loops, we could use the normal math, the normal algebra that we use every day. So we could just substitute values into this. So sum, which is equal to 0, but since it is a variable, we put it here in the left side. Sum equals sum. Now here, we will put the value of sum, which is 0, plus I. So since we declared I as 1, we should we should uh, add I to the sum, which is 1. So 0 plus 1 equals 1. So I would put here the value of sum, which is as of now 1. So now, since all the statements inside the for loop has been uh, has been executed, we should now use this statement, which is the I plus plus. So now I is equal not to 1, but equal to 2. So we have the sum, which is the value of 1. So sum equals 1, which is the value which we got earlier, plus the next value of I, which is 2. So sum equals 1 plus 2. So after this, the sum would get this value, which is 3. Then, since all the statements inside the for loop has been executed, we will now add an we would add I plus plus again to I. So I would now get 3. So so let us just fast forward this because it is kind of long. So let us say that, okay. So let us say that I is already equal to 10. So what would happen if I is already equal to 10? So you should always check the validation statement in the middle. So if I is less than 10, if I is less than or equal to 10, it should go in, it should still go in. So you should still add sum equals sum plus I. But since you already executed the statement, I will become 11. So when I is equal 11, for I equals 1, I less than or equal to 10. So is 11 less than or equal to 10? I think not. So since uh, since the validation statement uh, is false, we should now exit the for loop. So okay, so let's go back to our program. So always check the validation statement when program when using for loops. So here we have sum equals sum plus I. So let's print the sum, the sum, yeah, the sum of all numbers from 1 to 10 is equal to percent %d, which is sum. So let's run this program. And as you can see, oh, whoops, I forgot again to put the backslash n's, which will give space to the program. So here. Okay, so now it's readable. This will compute the sum of the numbers 1 to 10. So as you can see in the next line, the sum of all numbers from 1 to 10 is equal to 55. So if you want to validate this using maybe a calculator, you could try and you will see that it is correct. So this is a good use of a for loop. So, okay, so now let's move back to our slides. Okay, so here we have some basic C program outline. So here we have the introductory comments, which is so comments are used uh, in order to maybe comment out. I mean, how do I say this? In order to remove a certain line from the program itself. So we could do this by using two slashes or using a slash asterisk slash backslash. So header files or library files, this is what you usually see in the topmost portion of our program. So what I included in our program earlier was include stdio.h. stdio.h is a library which has functions. And these functions are the printf function, the for loop, and other things. That is why I wrote the stdio.h earlier. Next is the constant definitions. The constant definition is defining something in the function, but you cannot change its value throughout your program. So it is as is throughout the program. So if you, for example, here you type hash number sign define max 100. So max would be 100 throughout the program. You cannot change it whether you use a for loop to add one to it or something. It just won't change and it will just give you an error in your program. So function definitions, uh, so we will go in depth into this in the next topics. User defined functions. Okay, so this is what we created earlier. The main, so we created basically the main function earlier, which consists of your all your source codes when you're a starter programmer. So since we're just starting learning programming, we should not bother using functions yet. We should use the main function first when writing our program. So if you so if you don't understand some things in our discussion today, don't worry. We will have in-depth topics of this in the next module. So that is all for today. Once again, I'm Luigi from CBRC signing out.